1.4 is just diving deeper into lines, and so we're going to talk about the multiple equations of lines, or the multiple ways you can come up with an equation of line, depending what you're given. And we kind of saw that in 1-1. Remember, we got so many different versions of trying to come up with a circle, right? Like, they give you 2 endpoints of a diameter, or whatever it may be, okay? So what I want you to realize is, in general, they always want us to get to this mx plus b form. Okay, they always want us to get there. And so even if they're not giving us the m and the b right off the bat, they have to have given us enough information to figure out the m and to figure out the b. All right? So it says if we know the slope and the y-intercept of a line, we can find the equation of that line using the y equals mx plus b slope-intercept equation. So honestly, example 1 is like your best cut scenario. Notice what it gave us, a slope. So what is that? M, right? 7/8. And they gave us a y-intercept of 0.16, so what is 16? B, or y-intercept. So we can put it into that equation. So you might not rewrite it. I always like to rewrite it. mx plus b. So what's our equation going to be? Y equals what?
7/8.
Yep.
X plus 16.
You got it. There it is, folks. Just like our circle, x has to be there. Y has to be there, and the whole idea is there's an x that we can plug in, do the math, and a y will pop out, and we'll be able to graph the line, okay? So it says another equation, and I'm going to teach it, so if you like it, you can do it, but it's one of those things that you don't have to do it. Another way we can write lines, it's called point-slope equation, and what it is if you're given 2 points and not the y-intercept, you can still get to y equals mx plus b. So how they do it is they say, okay, let m be m, right? That's your slope. But then these are from the given point. So the ones, the x and y's that have that subscript, 1, x1, y1, is from the point they gave you, okay? That generic y, that generic x, they have to stay there because we want eventually y equals mx plus b. All right? So what I'm going to do is I'm actually going to do this in 2 ways, okay? Because I want to show you guys you don't have to memorize this. You can still use y equals mx plus b and get there, all right? So no matter what we do, though, both of these need a what? An m, all right? So let's look at example 2. It says a line has -2/3 and contains the point -3, 6. Find an equation of the line. So it gave us m, and it gave us an x1 and a y1, but this is not the y-intercept, correct? So I'm going to do it first. I'm going to kind of split it down the middle, okay? First using this method, the point-slope form, but then I'm also going to show you the slope-intercept form, how you can do it. So this is y minus y1 equals m times x minus x1. So again, I just like to write it generically so I know what I'm plugging in where. All right, so y stays generic, but y1 is the y from your point. So we're going to have y minus 6 equals our m, in this case was what? -2/3. Is that okay so far? And then parenthesis x stays generic. But what happens when we subtract a -3? It's going to become to a... Is everyone okay if I just go straight to that?
Yeah.
All right. So they are not going to want this equation given to you. So even though you have to use this format initially to get everything plugged in, they are going to want y equals mx plus b. So guess what we're going to have to do? We're going to have to distribute our -2/3 into both parts. So we have y minus 6. -2/3 times x is easy. It's just -2/3 x. And then -2/3 times 3 is not bad, but if it starts getting kind of hard, I just say throw it in your calculator. So you do -2 divided by 3 times 3, but this 3 up top is going to cancel out with that 3 on the bottom and leave you with -2. Is that what you got, Riley, when you put it in your calculator? All right. And then what's the one last thing that we still need to do? We want to get y by itself. So who do we need to move over? That's 6. And how are we going to do it since it's subtracted? We're going to add it. And we're going to add it just to this back constant, right? Because those are the only like terms. So this ends up being y equals -2/3 x. Is it plus 4? Is that what you guys get when you do all that?
Yeah.
Okay. Not bad, okay? But I'm one of those people, like, I hate, like, memorizing 18 different ways of doing things. So I want to show you that you guys can actually use the y equals mx plus b form. And what you're given is an x and a y, and you can plug everything in to find your b, okay? So this is option number 2. You can do either or. I'm not going to force you either way. Y equals mx plus b, okay? In this case, the unknown thing is the b. So we're going to fill in the x and y with our ordered pair, negative 3 and 6, and we're going to fill in our m with our slope, negative 2/3, do all the math to figure out that our b is 4. That's what we're trying to get at, okay? So what was our y in this part? 6. What was our m? Negative 2/3. What was our x? 3. Plus our unknown y-intercept, which is b. Is that okay? So we do our math. Let 6 hang out. What's negative 2/3 times 3? Oh, it's negative 3, isn't it? Sorry, that's my fault. What's negative 2/3 times negative 3? You should get positive 2. Is that what you get? And again, the negative times the negative makes a positive, and then this 3 on the bottom cancels out with that 3 on top. So that's 2 plus b, right? But we want to get b by itself, so how do I get b by itself? Minus the 2 over. So what is our b? 4. So now we have our slope and our b, right? So what is our equation of the line? Y equals mx, so negative 2/3 x plus b, 4. Has anybody seen it that way? I grew up being taught these two methods and memorizing these two methods. It wasn't until I started teaching that I'm like, you know what? Y equals mx plus b gets you there either way. Okay? So here, if we're given your m and your b, woohoo, that's easy. But even if you're not, you can use your x and y and your m to get the b and plug it in there. Okay? So it's up to you. And again, I'm not going to force you. You're like, I like this and it's not bad. Because I think so too. And to me, it's a lot less work and it's a lot less things for you have to remember. And that's all what I'm about. Okay? So let's look here. Example 3 is the same idea. We just have to do one extra step. We don't have a slope. Okay? So notice on example 3, we want to find the equation of a line containing points 2, 3, and 1, negative 4. As long as you have 2 points, can't you find the slope? We sure can. Okay? So the first thing we're going to do is we're going to find our slope. M equals y2 minus y1 over x2 minus x1. Okay? And again, it doesn't matter what you designate as y2 or x2. I'm going to kind of just always go in order. So my y2 is going to be negative 4. So negative 4 minus our y1 of 3 over, since I chose negative 4 first, I'm going to choose this 1 first because he goes with him, minus my 2. If you want to be a rebel and you flip the order, that's absolutely fine. All right, so negative 4 minus 3 is negative 7. 1 minus 2 is a negative 1, so we get a slope of positive 7. Okay? So how do we find the equation of the line? Well, we can do one of two ways. We can use the point slope form, or we can use y equals mx plus b. Which one do you guys want to do? Is that okay if we do the y equals mx plus b? So again, I'm going to write y equals mx plus b. And I realize b is who I'm trying to find, okay? Typically with y equals mx plus b, you want to keep the x and y generic. But in this case, we're going to use our specific x and y to help us find b, all right? Does it matter which y I use? No. But whatever y I use, I'm going to use that corresponding x. So I say try to go with the easiest point. Notice these are all positive numbers. So I tend to go with all positives or ones that have 0. Like, pick the easy of the 2 points. It doesn't matter though. You can be a rebel. You pick 1 and negative 4. I'm going to pick 2 and 3. We're going to get the same answer, which is kind of crazy. Okay, so I'm going to pick him. So my y is 3, my m is 7, and my x is 2. Does that look okay so far?
Yeah.
All right. So then what do we have? We have 3 equals, what's 7 times 2? 14 plus b. So what does b end up being? Negative 11, right? Because we're going to subtract the 4 over, yeah. So b ends up being negative 11. So now we have everything. We have our slope of 7m and our b of negative 11. So we have y equals mx, so 7x minus b. Not too bad. Doesn't that look so much easier than something like that? This is like a lot more concise and cleaned up. All right, so then on the back, if there's no questions there, go ahead and flip it. They are again showing you vertical lines, but they're not showing you vertical lines to say, oh, the slope is 0. What we're doing is we're going to start talking about parallel and perpendicular lines, okay? So anytime lines are parallel, we usually use this symbol like this, okay? The railroad tracks mean parallel. So parallel lines can be vertical or horizontal, right? So they can either be up and down right next to each other or sideways right next to each other, but most often they're at a slant, okay? What we want to pay attention to is parallel lines have the same slope, okay? So if they're two vertical lines, that means they both have a slope of undefined. If they're two horizontal lines, that means they both have a slope of 0. But if they're two parallel, I call them normal lines, they're going to have that same slope of 2 there. All right? Perpendicular lines are lines that when they intersect, they make a right angle. So the symbol for perpendicular, I don't know if you've seen it before, it's like an upside down T. It's showing you that when they meet, they make a right angle. Okay? So you'll see that symbol every once in a while. What makes two lines perpendicular is when the two slopes are negative reciprocals. So opposite reciprocals. Opposite means the signs are different. Reciprocal means one is flipped over the other. Okay, so opposite means the signs, positive versus negative, and reciprocal means flip the number. So what do I mean by that? If I have a slope of 2, the reciprocal would be 1/2. So the opposite reciprocal would be -1/2. Okay? If I have a slope of -1/4, the reciprocal would be -4, and the opposite reciprocal would be +4. So you switch the sign and the number. You flip it. Okay? And again, we kind of use the symbol. It's like a T. So notice here, it has a 2 for a slope, but then when you flip 2, you get 1/2, and when you change the sign, you get a negative. So these are opposite. Notice, this is kind of weird. This is like the only weird scenario where we can't necessarily do this math. A horizontal and vertical line are actually opposites of each other. And so opposite of 0 is infinity, and that's kind of the whole idea. So 0 is the horizontal, infinity slope is the vertical, so therefore they're perpendicular. Okay? So what we're going to do, a couple problems are just going to give you equations and ask, are they parallel, perpendicular, or neither? But we have to get them in that slope-intercept form, y equals mx plus b first, before we can compare them. All right, so this one we want to get y by itself. That's pretty easy. We have 5x already over there. I want him in front because I like him in front. So I'm just going to subtract the 2 behind him. Is that okay? So this is y equals 5x minus 2, like that. So what is that line's slope? 5. And again, I could even put minus 2 plus 5x, but the slope is still 5. It's always in front of your x, okay? So the slope is 5. All right? Let's look at the next sign. A little bit more work that we're going to have to do, okay? So we want to get y by itself. So I'm going to subtract the x over first, but I'm going to put them in front. So I have 5y equals negative x minus 15. Is that okay, guys? So I just moved my x over. Since it was positive, I subtracted it, and I put them in front because I want my variable in front. Then what do I have to do is divide everything by 5. And when I mean everything, I mean the 5y, the negative x, and the negative 15. When I divide him by 5, I'm going to put that fake coefficient of 1 in front, so I see the slope of negative 1/5, okay? So I'm going to divide everything by 5 real quick. Whee, divide by 5, okay? So y is going to be negative 1/5 x minus 3. Is that okay? Negative 1/5 x minus 3. So what is its slope? Negative 1/5. So after you do this and you get each other's slope, you ask, are they the flip in the opposite signs? They are, right? 5 flipped is 1/5, the opposite sign is negative, so these would be perpendicular. I would take that symbol, I would take perpendicular. I think on my math lab it's just probably an option, parallel, perpendicular, or neither, like you just click the right circle. Guys, we're going to do the exact same thing with the other 2 lines, where we're going to get them into y equals mx plus b format, so we can see their slope and compare them. All right? So we're going to get y by itself, so I'm going to subtract the 4x over first. Is that okay? So the 2y is going to stay the same, subtract the 4x in front, plus 8 hangs out, and then how do you get the y by itself? You divide every single thing by 2, right? So this is going to be divided by 2, 2, 2. So y equals negative 2x plus 4. Does that look right? For that first line, okay? I'm writing kind of big, but there's plenty of room over there. Notice the next line is almost in y equals mx plus b format, but instead of a y, it's a negative y, right? So I just want to divide everything by a negative 1 and switch the signs. And when I do that, I want to write it like the y on the left, the mx, that 2x in front, you know what I mean? So all I'm doing is dividing everything by negative 1. But when I do that, I'm going to kind of rearrange the order. So negative y divided by negative 1 is a positive y. I'm going to put him on the left now. A positive 2 divided by a negative 1 is a negative 2x. I'm going to put him in front. And then a 5 divided by a negative 1 is just a negative 5. So looking at these two lines, what are each of their slopes? They're both negative 2, which means they are what? Parallel. Guys, you might do all this work and one's negative 2 and one's 3. Then you just say neither, okay? So they don't always have to be one or the other. They can be oblique lines, meaning they cross, but in no special way. Is that okay so far? Am I good on the time? Okay. So on the top of page, oh, you are? Perfect. You're going to be my official timer for the semester. So on the top of page 3 here, guys, they're giving us the job to come up with what the parallel lines equation would be and what would the perpendicular line be. And all we have to remember is the slope, okay? So let's look at this. It says, write the equation of the line if it was parallel, and write the equation of the line if it's perpendicular, knowing that we want to be parallel and perpendicular to him, but go through this point. So I'm going to still use that method we used on the front page, y equals mx plus b, using this as my x and y to help me find b, but I need m. And m is going to depend on whether we're trying to make a parallel line or a perpendicular line. So let's isolate this y first to figure out what his slope is, so then we know what their slopes are, okay? So this is just going to be 4y equals x plus 20. Does that look right? Just adding that x over at first. And then what do I have to do to get y by itself? Divide everything by 4. So y is going to be 1/4 x plus 5. Does that look okay so far? So that line is who we need to be parallel to and who we need to be perpendicular to. So what I'm going to do is right above A, say what my slope needs to be. Well, what do we know about parallel lines? They have what kind of slopes? The same. So what's his slope? So this slope is going to be 1/4. So we'll keep that in mind when we do A. We already have our point, 2, -3, and now we have a slope, 1/4. What kind of slope are we going to have when we do part B, perpendicular? Well, what do we have to do to 1/4? Make it a negative and make it a 4. And typically anything over 1 we just write as that whole number. Yep, I wouldn't count off if you put 4 over 1. My math lab might. Okay. But it's good that you think that way because, Corey, not everything's a whole number, right? It might be 2/3, so when you flip 2/3, it's 3/2. Like, we can't get rid of that denominator. Guys, we have everything we need. So again, I'm going to just kind of split my page into 2. This will be A when we're doing the parallel. All right? So we'll have y equals mx plus b, where my x will be 2, my y will be -3, and I now know for a parallel line, my m is going to be 1/4, okay? So I have -3 equals 1/4 times my x of 2 plus b, and b is who I'm trying to find. So again, I would just throw that in my calculator. I don't expect for you guys to do fractional math in your head. If you want to, feel free. So we'll just do 1/4 times 2, which is just 1/2, okay? So this is -3 equals 1/2 plus b. And so to get b by itself, I would just take -3 minus 1/2, right? And I just put it in my calculator and hit math frac. What do you guys get when you do that? Yep, and if you hit math frac, because I think typically they like it as fractions. So what is -3.5 as math frac? You know where that math button is? That on the third on the left? -7/2, right? So b will be -7/2. You want me to help you with that? So I would just take -3.
Oh, -3
Yep.
minus. I was
Yeah,
typing it
so even
backwards.
negative 3, you're moving the 1/2 over. So negative 3 minus the 1/2.
And then,
And then hit math, enter. There you go.
yeah,
Okay.
I put,
The other, you're moving
Yeah.
the wrong direction.
yeah.
Okay, so now we have everything. Y equals m, which was 1/4 x, plus b, which is minus 7/2. And I know I kind of skipped it, but you guys are okay when you put plus b. If your b's negative, it's a minus, right, when you plug him in. So the line that would be parallel to 4y minus x equals 20, but passes through the point 2, negative 3, is 1/4 x minus 7/2. Okay? B, we're going to find the perpendicular line. All right, so we'll have y equals mx plus b, and we're going to fill it all out. Again, our x and y are still 2, negative 3, so we're going to have negative 3 equals m this time. That was different. It's negative 4 times 2 plus b. So again, we're trying to get b by itself, so I'm going to do that negative 4 times 2, get negative 8 there. But I want to get b by itself, so I'm going to add the 8 over. Is that okay? So b equals 5. Does that look right? So negative 3 was my y value, 2 was my x, negative 4 was my perpendicular slope. So negative 4 times 2 was a negative 8, but I wanted to get b by itself, so I needed to move that negative 8 over by adding it over. So my final equation is y equals negative 4x plus 5.
Wait, how'd you get 5?
I had negative 3, but I added 8 over there to get b by itself. So negative 3 plus 8 should give me a positive 5. All right, I want to show you real quickly on your calculator how you can check this, all right? So we don't do a whole lot of graphing until further into the semester, but if you're kind of curious to know, what you can do is you can graph all 3 lines and see what happens. So I'm going to put this up here. I think it's a little bit better if I show. I don't know, it's kind of ugly. Okay, so your y equals button's right below your stat plot. And I'm going to just make sure I have everything cleared out. Okay, so y equals, let's graph the very first line. The y equals 1/4 x plus 5, all right? So y equals 1/4, so you do just 1 divided by 4. And then your x button's right here by the alpha, plus 5. And hit graph.
I didn't pull up anything. It went down to y. How do you do that?
So I just went to y equals and plotted, oh, go clear all those things out. So that's beautiful. So when you hit graph, there it is.
Oh, I didn't
Okay.
hit graph.
Yeah.
Enter. Stupid.
So keep going. Okay. So then in y1, put their original equation, y equals 1/4 x plus 5. Okay, so that's the line that we want to be parallel and perpendicular to. Okay. So let's try this equation right here in y2, 1/4 x minus 7/2, and see if it's parallel, but also goes to the point 2, negative 3. So in y equals, go to y2 now, and type 1/4 x minus 7/2, and then hit graph. So in y2, plot our parallel line, 1/4 x minus 7/2, and hit graph. And see, you'll get a line that's not only parallel to it, but if you had to look at, it's hard to see, but 2, negative 3 we would hit, right? So 1, 2, and down 3, 1, 2, 3. It's that line right there. So we met both requirements. All right. This next one's a little tricky. So we're going to graph it, but I'm going to show you how you can change your viewing window so it looks perpendicular. The reason why it doesn't look perpendicular initially is because our viewing window is a rectangle, right? So it looks like it has a little bit more spread than it has height, so the angle looks weird. So in y3, into y3, we're going to type our last equation, negative 4x, oopsie, I don't know what I did there, negative 4x plus 5. And we'll hit graph. And at first when it goes through, it's like, that does not look like a right angle to me, like it looks like it's slanted. So if you hit zoom, and then notice it says square, it will make, it's number 5, it will make your viewing window square. So if you hit 5, when it plots that second line, or actually I guess it's the third line, it makes the whole viewing window square, so when it goes through, do you guys see more of a right angle there?
Yeah.
And so there's your perpendicular line. And notice, I know mine's right at the blur, But notice where these two hit 2, -3, because they are both supposed to go through 2, -3. We'll stop there.